to today's cosmology segment. It should be interesting, as we'll be, well, showing you various things here. So first of all, we're going to go over cosmic rays. Here is the cosmic ray situation at Apatit and Barentsburg over the past 30 days, which is this middle pane here. And you can see a downward trend over the past 30 days at the Apatit neutron monitor. Here's Barentsburg. Flat over the past 30 days at Barentsburg. Next, we'll go to Athens, Greece, which is much farther south. And there's the Athens neutron monitor. You can see a slight downward trend at Athens as well. Going even farther south to Mexico City. Small downtick at Mexico City over the past 30 days as well. Not a particular surprise here. And how about Oulu? So here's Oulu, Finland. Pretty flat over the past 30 days at Oulu. Let's check DOMB Antarctica. Small downtick at DOMB Antarctica. Here's DOMC Antarctica. Slight similar downtick at DOMC Antarctica as well. And that's the cosmic ray environment. Let's talk about a follow-up. So a couple days ago, we covered a story entitled Weird X-ray Surges Detected in Crab Pulsars Radio Bursts by NICER. Here's a follow-up to that. Mysterious giant radio pulses from pulsars are hundreds of times more energetic than previously believed. And this is a SciTechDaily.com article, so perhaps check that out, SciTechDaily.com. Interesting article here about the radio emissions of pulsars. This one in particular is about the Crab Pulsar, which is believed to have created a nebula in about the year 1054, as detected by Japanese and Chinese astronomers. And there's a bit of the signal profile of that. Again, this article will be all over the Science Wire. That one is from SciTechDaily.com. Let's pick a random number. It's 259, which will coincide with something at the Neil Gorell Swift-Bat X-ray Observatory. Let's see what it might be. And entry number 259 is Maxi J0758-456. Some sort of an X-ray source. It's only been monitored for about 5 years, as you can see here in the upper pane. It's a fairly consistent X-ray source. Here it is over the past 30 days. It's actually been weakening over the past 30 days there. And we can't show you this one on Simbad or Aladdin Light. So let's just pick another object here. And we're going to take a look at Cygnus X3, otherwise known as Deneb, the tail of the swan. And we just saw a massive X-ray burst from it. So there you go. And that's caused this graph to expand again. Is X3 going into an even louder X-ray state? If so, that's serious news, as Cygnus X3 is one of the more important objects in the Milky Way galaxy. It's the most intrinsically luminous object visible from our solar system. And we're trying to get people with radio telescopes to fix their gaze on this as it goes from an X-ray loud to X-ray quiet state. And you can see these transients here. Check this out, folks. These transients here, this is about 0.18 would be well off of this historic chart. 0.18 would be like up here somewhere. So some very high energy X-rays coming out of there of Cygnus X3. And we'll show you this on Simbad, the massive X-ray binary believed to be a Wolf-Rayet star orbited by an even more massive radio source at relativistic speeds, hundreds of kilometers per second. And here is X3 on the Chandra. So it's a very bright X-ray source. It's an object believed to be, I'll just call it a massive radio source, orbiting a massive Wolf-Rayet star, which is so huge that it would be about the size of Mars's orbit if it were in our solar system centered where the sun is. You'd be inside of it, actually. And it's more than interesting. Also, Göbekli Tepe is oriented toward Cygnus X3. And there's the massive companion object as viewed by Pan-STARRS. Here it is on 2MASS, and you can see there's clearly two objects there. And this right here, folks, is a massive disk of ionized gas and dust in between the objects. And if you want to read more about Cygnus X3, head to smashomash.com/forum in the Cosmology forum. You can read all about it. Check it out. It's sunspots drawn by Galileo in June of 1612. Now, here at the Smash News Network, we're very interested in facts like this. And so here, Galileo started drawing sunspots in June of 1612. And here are some of the first sunspot drawings by Galileo. And what we're talking about here is an article about the attempted reconstruction of the sun's behavior based on those drawings. And we can take a guess in terms of what the sun was doing based on the size, shape, and location of those sunspots. As we know, sunspots near the equator happen closer to solar minimum. Sunspots migrate toward the equator, folks, at solar minimum. And anyway, if you want to read this one. By the way Galileo counted sunspots was not by looking through a telescope. He used a helioscope where the sunlight would be projected onto another screen inside, as you can see on this image here. It's a helioscope, and you can pretty easily build one of these yourself. I won't get into it, as that is today's Cosmology segment. Thanks for tuning in, everybody. Thanks, Twitch. And I'm going to have to say goodbye to Twitch now. Bye, Twitch. As we continue on with the daily space weather. Patreon.com/smAshomash.